So if you're a data scientist, I bet you know this feeling all too well. You've got code that runs like a dream in your Jupyter notebook, but the second you try to get it into production, everything just falls apart. So what gives? Well, the secret isn't just about tidying up your script. It's about fundamentally changing the way you think about building software. Today, we're going to crack the code on the mental models that turn those fragile scripts into rock-solid, production-ready systems.
Here's how we're going to break it down. First, we'll talk about that infamous production wall. Then, we'll dive into 4 key programming paradigms. After that, we'll see how they stack up against each other, land on a really powerful hybrid approach, and then wrap it all up with a practical checklist for writing code you can actually trust in the wild.
All right, let's get into it. Section 1, from scripts to systems. So many of us in data science run smack into what we call the production wall. Your model might be brilliant, your analysis is spot on, but getting that thing to run reliably 24/7 in a live environment, yeah, that is a completely different ballgame.
And that really brings us to the core question, right? Why? Why does that beautiful notebook code, the stuff that works perfectly on your own machine, suddenly become so brittle, so hard to manage the moment it's deployed? Well, the answer usually isn't in the logic of what you're doing, but in how that logic is structured.
This is exactly where understanding programming paradigms becomes your secret weapon. Seriously, think of them as different mental models for building code. They're the fundamental styles that really shape how you attack a problem. So let's get familiar with the 4 most important ones for anyone working in MLOps.
First up, you've got procedural programming. Now, this is the default setting for most of us, especially in a Jupyter notebook. It's just a linear, step-by-step recipe of commands. You load some data, you process it, you train a model, you get a result. It's fantastic for experiments and getting quick answers. But as your project gets bigger, it can turn into this tangled web of code that's a nightmare to debug.
Next is object-oriented programming, or OOP. With this approach, you start to model your world using objects. So imagine creating a model object. This little package holds its own data, like its trained weights, and it also has its own behaviors, like a .train or a .predict method. This idea of bundling data and the functions that act on that data together is called encapsulation. And let me tell you, it is the absolute key to building large, organized systems that don't shatter the moment you change one little part.
Then we have functional programming. This paradigm treats every single computation like it's a pure mathematical function. The 2 big ideas here are immutability, meaning data never changes once it's created, and avoiding side effects. When you combine those, it means a function will always give you the exact same output for the same input, no surprises. This makes your code incredibly predictable and super easy to test. For data transformation pipelines where reliability is everything, this is pure gold.
And finally, there's declarative programming. This one is all about describing what you want, not how to get it. You just declare your desired end state and you let the platform or the framework figure out the step-by-step instructions. If you've ever written a SQL query or put together a YAML configuration file for Docker or Kubernetes, you've already done declarative programming. You just say, this is the result I want, and the engine does all the heavy lifting.
Okay, so we've got these 4 really powerful ways of thinking about code. But how do you actually choose the right tool for the job when you're working on an MLOps project? Let's get practical and break down the pros and cons.
This right here is the classic trade-off we face every single day. That procedural, script-like style, it's super fast, perfect for those quick and dirty experiments. But the moment you need to build a system that can actually grow, that can be maintained by a whole team, the organized, modular structure you get from object-oriented programming becomes absolutely essential for taming that complexity.
Now, this table really lays it all out. What I want you to focus on is that best for column. It tells the whole story. Procedural is for your rapid prototyping. Functional is for building those bulletproof data pipelines. Declarative is for defining your infrastructure. And OOP, that's the backbone for your large-scale applications. You see, there's no single winner here. It's all about context.
This brings us to a super practical question you're going to ask yourself every day. Should this piece of logic be a function or should it be a class? And really, the answer comes down to one simple word: state. If all you need to do is perform a stateless action, data goes in, a result comes out, no memory of what happened before, then a function is perfect. But if you need to bundle data together with the actions that use it, like a model that has to remember its own weights between calls, well then you absolutely need an object to hold that state.
And what all this shows us is that trying to be a purist, trying to stick to just one paradigm, is almost always a mistake. The most robust and effective MLOps systems aren't built with just one tool from the toolbox. No, they use a smart hybrid approach, one that combines solid structure with rigorous discipline.
So what's our recommendation?
For building scalable MLOps systems in Python, the verdict is pretty clear. Object-oriented programming should be your foundational paradigm. And why is that? It's because Python itself and all the major libraries you're already using, scikit-learn, pandas, keras, you name it, they are fundamentally built on OOP principles. You then take that solid foundation and enhance it with the discipline and predictability you get from functional programming.
So what does this hybrid style actually look like day to day? Well, it comes down to 4 key habits. First, prefer immutable state. Design your objects so they don't change after you create them. This prevents a whole class of unexpected bugs. Second, write pure methods. Have your methods return new values instead of changing the object itself. It makes testing a total breeze. Third, isolate your side effects. Keep all the messy stuff, like writing to files or databases, contained in one specific place. And finally, for any pure stateless logic, just use a simple standalone function. When you put it all together, you get the best of both worlds, structure and safety. Okay, we've covered the big ideas, the paradigms. Let's finish up by bringing this all down to earth. We're going to shift from high-level thinking to daily practice. This is how you move from just writing code to actually practicing your craft and building systems that are truly professional and reliable. Think of this checklist as your guide to writing professional-grade MLOps code. And seriously, don't let your eyes glaze over. These right here are the habits that separate a hobby project from a true production system. Like the single responsibility principle, it just means that each piece of your code does one thing and does it well, which makes it way easier to debug. Descriptive names, type hints, and clear doc strings, they're not just for you, they're a gift to your teammates and your future self. Handling errors gracefully is what lets a service run for months instead of crashing at 3 in the morning. And last but not least, unit tests. These are your non-negotiable safety net. They prove your logic works today and, even more importantly, they stop it from breaking 6 months from now.
And that brings us to the end. I want to leave you with a direct challenge. Take a look at a project you are working on right now. What is one function, one class, just one piece of code that you could refactor using these principles today? Because starting small, right now, is the absolute best way to build the habits that will take your work from the notebook to production. That's it for this explainer. Keep building.